My name is Bobby Birstock. I'm a partner engineer here at DBT Labs, and I'll be going through the beginning of this quick start with you to get you all set up and ready to build a fully functioning DBT project. From there, I'm going to pass you along to Hope Watson, also on the partner engineering team here at DBT Labs, to take you through the actual building of the DBT project. But before we jump into the quick start, I want to touch on how we'll be using DBT Cloud to demonstrate these four key outcomes of the DBT development framework. So these four outcomes are collaboration, velocity, quality, and governance. So it fosters collaboration among team members, making sure that everyone that knows SQL, as well as our newly added Python functionality, can contribute to your analytics project. It allows you to ship new work quicker, and this is where DBT Cloud really shines, because instead of having to build and manage a large suite of infrastructure tools, all you need to do is log into your DBT Cloud account, and you're on your way to creating a fully functional analytics pipeline. So velocity increases significantly, but we still want to do this without sacrificing quality. So we'll show you how easy it is to test not just your work, but all of the work being done across a project. And finally, it provides a strong platform to implement governance processes for your data workflow. And again, we'll be using DBT Cloud to do all of this and show you how quick and easy it is to achieve these outcomes for your data team. Alrighty, let's get to it. To get started, we are going to start on the Quickstart's site. So quickstarts.snowflake.com. Make sure that you are there, and you can type in accelerating data teams into the search bar. That should bring up a couple different options here, but we want to pick the one that is the DBT Cloud Quickstart. So it has DBT Cloud in the title. Once you've found that one, you can click Start, and that'll take us to the Quickstart itself. We'll actually start here on the overview page. And everything that you'll need for this quick start is contained within the quick start itself, or at least it'll provide links to go to anything else that you might need. So we're going to build a DBT project on top of Snowflake, and we are going to do that step by step from beginning to end, and creation of the DBT project all the way through creating your data pipelines with DBT. And I'll be helping you to get started by getting your Snowflake account spun up, and then I'll be handing it over to my colleague Hope Watson to take you through the rest of the workshop. Now, a couple key things that I do want to mention as far as what you'll be using here in the lab. So we'll be using a trial Snowflake account. Now, for everyone that already has a Snowflake account, I still highly recommend that you'll create a free trial with us. So we'll be going through this in the next step, but basically, the process of creating the DBT Cloud account we'll be doing through Snowflake, through Partner Connect. And by going through the process with a free trial account, everything is a bit easier. The permissions also are a bit easier, at least making sure that we're using a DBT Cloud account that's created through Partner Connect. Make sure that all of our permissions line up throughout this workshop. And I highly recommend that you do it. It's still possible if you don't, but you might encounter more difficulties than if you went through the process of creating a trial account. And as far as what you're going to learn here today in the Quick Start, we're going to build scalable data transformation pipelines using DBT and Snowflake. We're going to look at a few of the testing capabilities that DBT provides you with. We'll scale Snowflake compute capabilities with the DBT workflow, and then we're probably not going to have time for it in the workshop itself, but you'll have the ability after we're done here to build lightweight charts and visualizations in Snowflake as well. And then as far as the actual building, we're going to build a set of data analytics pipelines using some retail data, and we'll also be again implementing tests and looking at how you can promote code between different environments using DBT and manage those environments as well. So let's get started. Before we go into any actual building, I do want to give a little architecture and use case overview here. So to clarify where DBT fits into the data ecosystem and how it works with Snowflake, it's the transformation layer that sits on top of a data warehouse like Snowflake. So in this graphic, you've got your source data that is feeding into Snowflake. And then once it's there, it needs to be cleaned and transformed to meet your business needs. And that's where DBT comes in. And you can use DBT to build these transformations. And then when you're ready to run your SQL, DBT will take all of the queries that you've built and push those down to the warehouse to run. So DBT is serving as an interface for development and deployment, but at the end of the day, all of your SQL is being run in your data warehouse, and you're going to see that in action as we move through the workshop. And I should also mention that, of course, you're getting a lot of really great features by going through the DBT workflow, testing, documentation, dedicated development and production environments, and then, of course, everything being tracked with Git. And also should mention here, as you can see at the bottom, we've got a cool bit of model lineage that we'll be creating using DBT as we move through the workshop. Okay, so getting started with Snowflake. So I've definitely harped on this a bit, but do want to mention again, we want to create a Snowflake free trial account. So I'm going to go through that process here, and everyone should also go through that process. So feel free to follow the link that we have here. I already clicked on it and opened up a new tab, but let's create that Snowflake for free trial account. So I've got mine getting spun up now, and feel free to choose the Enterprise Edition here. It doesn't really matter, but yeah, keep it on the Enterprise Edition. Cloud provider does not matter, and you know, the location of the server also doesn't really matter. But yeah, once you've clicked Get Started, should take a quick second for that account to spin up, and I'll be right back with you once mine is ready to go. Alrighty, so I've got my new account created. I hope that you have as well, that you put in your username, password, got it all set up here, and that you are at this home page here. And from here, we'll keep going through that section 3 in the guide. And the next step is to check to make sure that we actually have the data that we need in order to transform and go through the project and go through the workshop. So if we go into our Snowflake account, let's start by clicking on Worksheets. And from Worksheets, you can click on the plus worksheet button in the upper right-hand corner to create a new worksheet. And here, first thing we'll do is click on databases. So if you click on databases, you should see 2, and one of them is called Snowflake Sample Data. That's the one that we're interested in. When we look underneath that, you should see the TPCH SF1 database and, the TPCH SF1 schema within the Snowflake Sample Database. And from there, that is where we have all of the tables that we need in order to serve as our raw data, and that we will be transforming throughout this project. But just to make sure that you actually have access to this, let's query that data to make sure that we're getting some results. So to start with, if you're like me and you just created your free trial account, you probably don't have a warehouse, in which case we need to create one. So let's do that. And we can use the create warehouse command. I'm just going to call mine sample warehouse, and with the warehouse size equal to X small. So let's run that. And that was successfully created. And then from there, what we'll do is we can hop back over to the guide, scroll to the bottom of section 3, and then I'm just going to copy and paste this select all query, save myself a little bit of typing, and feel free to do so yourself. And as a kind of a word of advice for the rest of the workshop, feel free to copy and paste everything that we're copying and pasting. We don't want you to have to waste any time typing stuff out if you don't have to. So anyways, I threw this query in here. Let's make sure that I've actually selected my sample warehouse to use, and let's run that query, and we should get some results like this. So if you're seeing this on your side, that means that you also have access to the data that we need in order to keep moving through the workshop. And we're ready to move on to the next step, which is creating your DBT Labs account through Partner Connect. So let's do that. I'm going to head back over to the guide, and we'll go to step 4 here, which is launching DBT Cloud via Partner Connect. So the Partner Connect process is really great and really cool. and it's going to create a bunch, not just your DBT Cloud account, but it's going to create a bunch of the, objects that we need in order to actually, make this connection work. So we'll see that here as we move through the process. But we'll start with going back to the home page here in Snowflake and clicking on admin. And this is also, I should mention, for folks that are in the new Snowflake UI, if you're using the classic Snowflake UI, this might be a slightly different route for you to get to the Partner Connect page. However, you can still do it. It's there for you, and the DBT tile to make the connection with DBT Cloud is going to work exactly the same, regardless of whether or not you're using the classic UI or the new UI. So I'm going to click admin here in the new UI and then click on Partner Connect. And then from there, I can search here at the top for DBT, and you should see the DBT tile pop up, and let's click on that. So these are the objects that I was referencing of what's going to be created. So Partner Connect is going to create this database for us. It's going to create a new warehouse for us, as well as a system user with an auto-generated and randomized password. And then we've got a role connected with all of this as well. And we want to make sure that all of all of the stuff that we're creating is going to play nice with that sample data that we're using as our raw data. So we are going to make sure that we provide grants to that raw data for for this role. So let's just pop back over, and show you how that looks here in our screenshots of the guide. So the Snowflake sample data warehouse is what you want to put in with to the optional grant piece within the pop-up window. So if I go back over here to Snowflake itself, and I start typing in Snowflake, you should see the Snowflake sample data database pop up there. Select it. And once you've got that selected, you are good to go. So from there, you can click connect. And this takes a little bit, a few seconds to spin up, but this is now creating your DBT Cloud account. And from here, once it's done, we'll be able to go over to DBT Cloud and finish it all up. And so, okay, cool. Looks like we've done that. So I'm going to click on activate to take us over to DBT Cloud. And I will mention, my flow here is going to be a little different than what you're going to see on your side. And the reason why is because I already have a DBT Cloud account associated with this email address that I use to create my Snowflake free trial account. So for everyone that might have gone down that route, you already have a DBT Cloud account and you're creating a new one through Partner Connect. Don't be afraid of this particular flow that you're seeing. I'm going to type in the name of the account as Snowflake Partner Connect here and agree to the terms of service to complete the registration. And then once I've done that, I will then log back into my existing DBT Cloud account or use my existing user to sign in to then be able to access this new Partner Connect account with that account name that I just put in to go through the rest of the workshop and the Quickstart here. For everyone else that is doing this for the first time, I'll pop back over to the Quickstart guide to show you what it will look like on your side. So what you should have seen, again, the activate screen and window pop up in Snowflake, and it should have redirected you to a screen in DBT Cloud that actually lets you put in not only the account name, but a password. So that's the only difference. It's really not that much. I kind of overplayed it here, but the password is the only thing that you're going to need to input if you haven't created a DBT Cloud account before with this same email address. And then regardless, for everyone, once you complete it and you've logged in, you should be able to see your DBT Cloud account and the most basic homepage for you to then get started with the rest of your project. Now, the other thing that I want to mention as part of this registration and account creation is that we have created a managed repository for you to get version control all of your work. So the version control process for this Quickstart is kind of happening in the background a bit, or at least the repo is being managed. There is a way for you absolutely to, when you're developing your own project, to use your own repository. And there's a couple other really great features that you can use when you use your own repository. But just as a heads up, that repo has already been created for you as part of the Partner Connect process, and it will be ready for you when you get into your DBT Cloud account. So, okay, that does it for me here with the initial setup and getting your DBT Cloud account ready to go with your Snowflake free trial account. I'm going to hand it over to my colleague Hope to take you the rest of the way. So, yeah, take it away, Hope.
Thanks so much, Bobby, for helping us get set up on Snowflake and getting connected into DBT Cloud. I'm Hope Watson. I'm a partner engineer here at DBT Labs, and I'll be taking you through the rest of the course today and how to build transform models using DBT. So for today's demo, we won't be going through each of the steps. We'll be skipping 2 areas today in this demo. So this will be step 8, seeds and incremental materializations, in addition to 12, visualizing your data with Snowsight dashboards. So these are some really great topics to revisit within the Quickstart, but won't be in the scope of this demo today. I'm going to go over into our DBT Cloud area, and the first thing I'm going to do is hit develop. This will take a few seconds to load. Great. Now that we've loaded up, we're ready to actually initialize our DBT project. So I can hit this, and this is going to create our file structure and explorer for the duration of this project. Now that we've initialized our project, we have this file structure to work with. So the next thing we're going to do is we're going to commit this initial project that we've created. Now, right before I do this, there's one thing that I'm going to repeat actually twice because it's so important. This is the only commit that we are going to have directly into main. From here on out, we're going to be working in a development branch. Now, the reason for this is we want to keep our development and our production code separate so we don't cause any breakages. So once again, this is the only commit that will be going to main from here on out. So let's initialize our project. That's our commit message for this. So now that we've committed our initial branch, we're working within this IDE within DBT Cloud. So Integrated Development Environment is what IDE stands for. So we can see we have a couple things going on. We have a text editor in this main area. We could see this by creating a new file. We have a SQL runner, which we're able to do once we've created our SQL here. We have our command line down here. So this is where we can run things like dbt run, which I'll do in a minute. We have our file tree that we've already talked about, and we have our Git controls. We're now ready to run our first DBT models. The reason that we're able to do this is that when a DBT project initializes, it comes with these first 2 models. So to run these 2 models, we're going to do dbt run in the command bar and hit enter. And now we can click into our second model here. We can see it completed successfully. And we're going to go into the details to see where this model has been built. So we can see that it's been built within the PC_DBT_DB database, and now it's within my own personal development schema, DBT H Watson. To confirm that this has actually happened, we can go into Snowflake, we can go into data, we can refresh to make sure that what we just ran will be reflected here. We can click in, and look, we can see we have created my own development schema by running our DBT job. And we have our first model, and we have this view that we've created. Great. So while we're in the Snowflake environment here, we want to go to worksheets. And the next thing we want to do is we want to create another warehouse. So once again, all the pieces throughout this code, all the pieces within this quick site, feel free to copy this code. Definitely don't type it out. We encourage copying all the code here. So I'm going to copy it and open up a worksheet. And what I'm doing here is I'm using my account admin role to create a larger warehouse size, and I'm going to grant it all abilities to sort of read, write, and do all those things. So, yep, statement was executed successfully. We can go in here and confirm that I've created that warehouse here, and I have it. This wraps up our step 5, and we're ready to move on to setting our foundational structure in our DBT project. So to set our foundation for this project, we're going to go back over to cloud. The first thing we're going to do is we're going to create a branch. So this will be our development branch that we're working on throughout the project. And we're going to call this Snowflake Workshop. Submit. So now we're working on our development branch while we work on this project. So the next thing we're going to do is we're going to go to our DBT project YAML file. So this is the file down here at the bottom, and it should look like this when your project first starts up. So you click on it, open it, and now what we're going to do is we're going to go back over to our demo, our Quickstart, and we are going to update our YAML file here. So instead of having the default, we're going to update this, and so we have a couple different warehouses. Great. Now that we've updated our DBT project YAML using the code in the Quickstart, there's 2 specific configurations that are important to point out here. The first is the materialized, and the second is the Snowflake warehouse configurations. So I'm going to elaborate on these a little bit more now. Materializations are the strategies that DBT uses to create the table within Snowflake. Typically, this is tables and views being the most common. By default, all DBT models are materialized as views, and other materialization types can be configured both within the DBT project YAML right here, and also within the model itself, which we'll do a little later. Based on the configuration in our DBT project YAML file, DBT will materialize all of the models in the staging files as views and all of the marts as tables. DBT uses a hierarchical model for configurations where any model configuration overrides the DBT project configuration. Easiest way to think of this is wherever you're specifying it in the most specific area within that model file is typically the top of the hierarchy, and the more general configurations would be lower. So the benefit of using these DBT materializations is that when you execute a model, DBT will automatically use the right DDL associated with this materialization to create the model's equivalent in a data warehouse. This allows for this bespoke creation flow, so you can just focus on writing the SQL statement and not worry about all that DDL creating as a view, creating as a table, and having to write those statements at the top of your SQL. The other configuration we want to focus on is the Snowflake warehouse configuration. So each DBT connection declares a warehouse when it's building models in Snowflake. It needs to know what compute space to use. So with the Snowflake warehouse configurator file, we're going to use this extra small PC DBT WH. So I'll probably refer to this as the small warehouse, or the extra small warehouse throughout. And within then our marts view, we're going to be using our larger warehouse, so PC DBT WH large, to build everything in that marts folder. What these different configurations allow us to do is to scale up and scale down our warehouse size based off the compute needs that we need for different parts of our project. So we only use the amount of compute we need and no more and no less. So materializations and warehouses aren't the only types of configurations. We've given that example here. There's tons of other configurations you can apply, and those are found linked within the Quickstart to learn more about this. You can even configure your models, your seeds, and tests, so it's great to check out more there. The next area that we're going to focus on is our folder structure while we're setting this foundation. So DBT Labs has a project structure guide, also linked in the Quickstart, that contains a number of recommendations for how to build the folder structure of your project. The folder structure we'll be building in this lab follows this guidance and fits into these following categories. So the first one is sources. This is our TPCH dataset, and it will be defined in a source YAML file. The second area is the staging models. These models have the one-to-one relationship with our source files and serve as a place for renaming, recasting, and generally really light transformations that we will use consistently throughout the rest of our project. Then we have the marts models. So these models represent the business processes and entities that are abstracted from the data sources that they're based on. Here's where we're going to perform most of our transformations and really be that main area of focus on our project. By having defined this project structure, even if you don't use this exact one for your use case, you can create a predictable file tree, so there's never guessing which folder a model should exist in. So we're going to implement our folder structure here. And because we have quite a few folders to create, we're going to use a shortcut to build a couple different folders at the same time. So to do this, click on the 3 dots in the models, go to creating the folder. And the first folder that we're going to create is going to be called staging. And this is going to be for the TPCH data. So we want to have that source specified. Okay, cool. And you can see that we have that within staging and TPCH. Great. So the next area that we're going to work on is we're going to create a MARTS folder. So we're going to go into here. We're going to create another folder. And this will be called MARTS core. And we can see MARTS and core there. Great. So now that we've have these folders set up, this is where we're going to be placing our transformation models and our staging, which we'll do in the next section. The last piece of this foundational setup that we'll have is adding packages. So DBT packages are essentially DBT projects that you can bring into your own project and use that code as if it was your own. This is similar to a library in Python. So many packages are hosted on the DBT Packages Hub and provide you with the ability to generate reusable code for creating DBT sources and models. And this helps you access a variety of helpful macros in Jinja and build database constraints for Snowflake databases. So before it seems like throwing around all these buzzwords, what is Jinja? What's a macro? So let's break it down. Jinja is a Pythonic templating language that you can use in DBT to do things that normally aren't possible or easy to do in SQL. So some examples include building control structures and flows using if statements and for loops to abstract code snippets into reusable macros. So you can combine Jinja to help create this macro. And this helps create code that you don't repeat yourself, known as dry principles. So we're going to keep thinking about don't repeat yourself code. And this macro is a piece of Jinja code that can be reused multiple times in the DBT project. It's like a function in other programming languages. Some of DBT's most important functions, like source and ref, which we'll see, are also macros that we'll cover later. If you can find yourself repeating a common SQL transformation throughout your projects, chances are there's a macro in the package that you can use to make your life easier. Always check a package. If someone's done it before, don't reinvent the wheel. Help yourself out and use their code. If there isn't something, you can always build your own macro and help yourself out or your teammates by having that reusable macro, like I said, like a function. We won't be writing our own macros in this workshop, but we do recommend checking out the Jinja docs and the documentation to figure out how to get leveled up. And remember that we declared our warehouses in our DBT project file YAML. Well, there's a macro that we could actually make that process easier as to when which warehouse is used here. So we could have used a macro for that even. We're going to be using the DBT utils package in our project. So in order to do this, we need to create a new file at the level of our project, also known as the root directory. So we're going to create this file. We're going to call it packages.yaml. So make sure you have that at the root level and it's appearing down here right next to your project. That's the level it should be on. Now, what we're going to do is we're going to pop back over to our Quickstart and we're going to copy this in here. We're going to paste it. We're going to allow it. Clipboard, we're saving this to make sure that we've saved our packages file. And the next thing that we're going to do is run dbt deps, which stands for dependencies. And this then allows that command allows us to bring in the packages that we have loaded, that we've specified in this file. So we run dbt deps at the command line there and we hit enter. I'm just waiting for this to finish up. Great. So we've done everything right. We see no compilation problems down here at the bottom. And before we move on to our next section of creating the sources and staging, we want to commit these changes. We're working on our development branch, so this is the right place to do it. So we're going to commit. So we're just going to say set up structure for our project and commit those changes. Great. And that wraps out the step for our foundational structure. In this next section, we're going to talk about sources and staging. Sources in dbt allow you to describe raw data from your warehouse in your dbt project. And what this does is it allows you to establish a lineage from your raw all the way to your transform data. When you define your sources within your dbt project, you're able to apply the same testing and documentation best practices to those that you would in your transformed models. This is really important because sources on test allow you to make sure that your data quality is what you expect it to be, such as the completeness. Second thing is staging. We've talked about a little bit in the last section. So staging models have this one-to-one relationship with source tables. And this is where we perform those simple transformations, recasting, and altering the columns to a more usable format. So building staging models provides this clear foundation for your downstream modeling to build upon and keeping modularity in mind. So if your logic ever changes, then you only have to change one staging model instead of 5 within the same subquery. A really good example of this is if you have the same pesky column that you keep recasting from a string to an integer. Probably could go into a staging model and you can do that once upstream and then leverage it downstream. So we are going to create our sources YAML. And to do this, the first thing that we want to do is we want to go into models. We want to go to staging. We want to go to TPCH and we want to create a file. And we're going to call it TPCH_sources.yaml. Great. Now what we're going to do is we're going to go back to our Quickstart and we are going to take this sources YAML. We're going to copy it in, paste it, save it. And in the file, there's a couple key things to point out. The first is that this data is coming from that Snowflake sample data that we have over in Snowflake. And it's also coming from the TPCH SF1 schema. And so we'll be able to build on top of these sources to create our transformations. Finally, below each table name, we have our descriptions and we have tests, and we'll be covering these in the documentation section. Now that we have these sources in place, the next thing we want to do is create those staging models. And these are going to be SQL files. So what we want to do is we want to go into our models area. We want to go into TPCH again. We'll be creating another file. And this time it's going to be stage TPCH_orders. We're doing this for orders, and then we'll do this for line item. Really important to note here, this is going to be a .SQL file instead of a .YAML file. Okay, great. Now what we're going to do, we're going to go back to that Quickstart, and we're going to bring in our orders table here. I'm sorry, our staging table here. We're going to save that. All we're doing here is pulling the source data into the model that we can see using the source function, which we'll talk about in just a couple minutes. And we're doing some column renaming, as you can see here. And this serves as a starting point for models that need to reference this data and have this consistent naming convention throughout. For the second model, our line items table, we're going to go in, we're going to create a new file. And this time it's going to be staging, still coming from TPCH, but this time it's going to be the line items table. This is also a SQL file because this is the transformations we're doing in the staging layer here. So this will be our staging line items table. And just like before, I'm going to go back in we are going to copy our code for line item this time. I'm going to paste it in. We're going to save it. So there's a couple key pieces of information that are going on within our staging line items model. So we're still using the source function here. We're renaming some columns, but really importantly, we have this dbt utils function that's referencing this macro called surrogate key. And what this does is this creates a hashed surrogate key that we'll call order item key, that we are using the order key and the line number to create this. So implementing the surrogate key gives us one unique column that we can use to easily test for uniqueness later on in the lab. You can find more information within the Quickstart link about some of the key macros for your project. Let's toggle back to our first orders model so that we can talk about the source function. So here we have the source function, and there's a couple reasons why you would use this instead of a hard-coded database reference. So you know where you have that schema and that table string. Instead, we're using the source function here for the schema and the table. And one thing that the source function does extremely well is that it creates a dependency between our source objects and our staging models. This is going to be really important when we take a look at our data lineage later on in the workshop. Defining sources and referring to them with the source function allows you to test and document these sources as you can with other models in your project. And if your database changes or your schema changes, you only have to update it once in the sources YAML that we created, rather than updating all the models that it might be used in. And we can see as we've created our source function here and we have our staging, that this has started to build out this small lineage for us, but this is going to get bigger throughout our project. We've defined these models in these files and we've saved them, but we actually haven't built them in Snowflake yet. We haven't run the models. And so that's what we're going to do in this next section. So what we're going to do is we're going to do dbt run, which will now include those two new staging models that we've built. We can see those popping up. Awesome. They all ran. We can see that this is true because of our 4 green check marks and the 4 models that passed here. So a really important concept related to this run and in dbt is that it's an example of an idempotent process, which means that the output is the same after each execution, no matter how many times the process is executed. So I could go down here to the command bar and write dbt run, dbt run, dbt run, and my staging models would be the same each time. And this is really important. It's one of the key tenets of dbt to maintain these kinds of workflows for best practices. To make sure that we've actually built our tables in Snowflake with that successful run, we can go back over here. We can go into my schema. We can see the views, and we can see that I've built these 2 staging models. So we have the columns, the data preview. So we've successfully done that, and now those objects are available within Snowflake. So before we move on to the next section about transforming our models, we need to actually commit and make sure that our changes are good to go. So everything's saved. I'm going to commit, and we'll call this sources and staging, since that's what we've set up. Great. And that wraps out the sources and staging section. Let's talk about transformations. Transformed models is one of my favorite topics and steps in a project, because this is where we get to create these kind of joined tables that create a lot of business logic and insight baked into our pipeline, and we get ready to feed typically the BI layer. So this is the layer that's going to create a lot of insight, and usually it's what your end users are going to be able to see as well if they interact with the BI tool. So our plan for this part of the project is to build 2 transformation models. The first one is an intermediate model that won't be sort of our final view. That's why it's called intermediate. And the second one will be called a fact table. And this will have both calculations at the line level and our order level. And so in order to create this, as we've been creating things like our staging models, we create those new files. We're going to do the same thing, but we're going to do this now in the marts and in the core folder. So just like before, We're creating new models. This one we're going to call int order items.SQL. Once again, that int stands for intermediate, not integer. So this is an intermediate model. We're going to create that file. As we've typically been doing when we create the file, we're going to go in and fetch that SQL code from the Quickstart. So we're going to copy this. Whoops, went to Snowflake, meant to go to my IDE. I'm going to save it. Great. There's a couple things that you saw happen when we did that. You saw this lineage changed because of these references that we're putting in. So we're going to unpack this statement here right now. So there's a lot going on within this SQL statement. So let's break it down bit by bit. So at the top, we're selecting our data from two of these common table expressions in our staging models. So we can see this here in the code, and we can also see it down here in our lineage for both of these. And then we can see that the main statement down here is joining these two staging models together, and it's pulling a chunk of our existing columns directly from our orders and from our line items table. And then we're also creating a number of important calculations that we're going to want to use in our fact table downstream. So this is our base price, discounts, things like our sales tax, and then the net item amount that was created. And all of these different calculations are points of interest, things that we're going to want to put into our BI tool, either in an aggregated form or otherwise. And these weren't calculated in our raw source data. So we've been able to create more information and already more value at this stage and track how it's been coming from end to end. So to talk about the ref function more in depth, this is really the most important function within DBT. And this is for two reasons. The first one is you are automatically creating these dependencies when you use the ref function, and DBT can recognize that. So if you see a hard-coded schema and table in your code, the best practice here is always going to be to replace that with the ref function. So every entity and every model that you have is tracked throughout your project with the correct dependencies. The second reason is that when we want to promote our code to develop environment into that production later on, as we'll see in the lab, the ref function allows us to compile to the correct database object associated with that production environment. Now that we've made the intermediate model, we want to make the fact model. So we're going to do a similar thing. We're going to create a new file. We're going to call this fact, FCT, short for fact, orders. It's kind of a hint here that we're probably aggregating from the line level. So one order can have multiple line items. So you could have multiple things in a single order. So we're probably going to aggregate it and use a group by statement. So let's go over here and grab the code to create this model, our facts model, paste it in, save. And just like before, when we were adding our int model and we saw that lineage update, we can see our lineage updated now. So we're finally starting to build out a nice little pipeline here. Now, what's interesting and happening in this model is we are in fact grouping. So what we're doing is we're taking those line items and we're aggregating them to the order level. And what this is letting us do is have information at our order level, such as the date of when it occurred, the status code, its priority, and importantly, maybe the shipping priority. And then we can understand some information about how much was actually spent, what was discounted, and what was the net. So this might be really interesting to look at from a perspective of if you have some really small order amounts, but with high shipping priorities, how you might want to go about prioritizing those in your business as to when your customer gets that order. So we can see we're creating a lot of good information with just a few steps here. Similar to our staging models, now that we've created the files, we've created two of these files, but we haven't actually run these models and created our intermediate and fact table within Snowflake. So we're going to do this now. And instead of just doing the normal dbt run flavor that we've been working with, we're going to do dbt run, and then we're going to do select int order items, and then with a plus sign at the end. And we'll go through this while it is running. So break it down. So I made a syntax mistake. I forgot to put dbt run, so it didn't know what to do. Let's try that again. So we need to tell dbt what to actually run for it to be a valid command. Okay. Cool. And now we've built out these two models. Let me walk through what this now correct syntax is doing here. So the run function is building the models, which I forgot that first go around. What that select statement is doing is it references a specific model or path that we want to build out. In this case, we are referencing our in order items. And what that plus sign is doing on the end, this is one of my favorite dbt features, is it is saying build everything that is a downstream dependency of the in order items, which includes our fact orders as well. So that's how we were able to not only build our in order items, but you can see we also built our fact order items. You can also check out other operators. So in addition to the plus sign, you can use the @ sign, and you can also use the star. And one of the other cool things that you can do is you can put it in the front. So I could have put the plus sign in front here, and that would have built everything upstream. So you don't have to worry about your dependencies there. dbt recognizes them and runs it for you. Now that we got the right syntax on that last run there, we can go into fact orders and learn some information about where it was run and how this code compiled and what was actually sent to Snowflake. So one of the things that we configured in our project YAML file was to have our marts table run on the larger warehouse, which we can see it did here. So we used our bigger compute to create our fact orders table. The other thing here is that dbt by default, as we talked about, creates views, but instead we wanted our marts tables to materialize as tables. Sorry, our marts folder to materialize as tables, which we can see the DDL is automatically being created, and that will in fact be a table. This is going directly into my development schema, and we can see that entity is being created. One of the key things to point out here that the ref statement allowed us to do is this reference statement that we had up here for the TPCH orders has interpolated and created both the database and the schema. So that also got picked up within our query, and we were able to create our fact orders object that way. Now, clicking out of this, we can go back down to our lineage. We can see that it's really starting to come together here. And this becomes, as you can imagine, a lot more powerful when you have maybe even dozens or hundreds of nodes and different models that are being created. So here, if you want to navigate back to a specific node, you can click either on the object within the lineage, or you can go back up to your file for that as well. And what's really cool here is on the left side, you have these green source nodes, and then we have our blue modeling nodes along here. This was all made possible by using the ref and source function that automatically creates its dependencies. So once again, we've kind of wrapped up this section. We want to make sure everything's saved, which it looks like it is. And we have these U's next to here because this is still uncommitted. So our final step in working with these transform models is to commit them. And we created intermediate fact models. And those changes are committed. And now we're ready to talk about tests and documentation. Now that we build our models and transformations, it's really important to test and document them. You might be thinking by this point in the demo, is every part of this important? And it really is. So we need to have our development, so the project and code actually exist to create these models. We need to be able to document so other people on our team know what is going on with this project, and probably ourselves in the future as well. We need to test them to make sure that we are capturing our assertions. This is both on source to make sure that the data is ingested as we thought, and also to test our transformations so we haven't introduced bugs. And the final thing is actually deploying this project. We'll talk about that a little bit in the next section. So one of the things that I really enjoy about DBT is that the coding and testing and documentation are done at the same time. Can't tell you how many times when I was working as a data scientist that you go through this entire technical project and you get the code to run only to have just inline comments or saving the documentation for the very last, and then it never happens at all because you move on to the next project. That is so hard, and you may not even be able to read your own work in just a few months, much less a team member following your logic. So this is really important to take the time to do it side by side while you're coding. And so testing comes in two flavors within DBT. You have generic and singular. And the singular testing is really in its simplest form. If you can write a SQL statement that returns failing rows, you can execute this as a DBT test. Generic tests are the same, really, but with one difference, and that's the ability to accept arguments. So instead of having a hard-casted column that you're testing, you would actually have that as an argument. And you would name it maybe columns, right, that you want to select as part of that generic test. So you can define them in a test block, which is similar to a macro, and once defined, you can reference them by the name in those YAML files. You can apply these to models, columns, sources, snapshots, seeds, and more. So DBT ships with these 4 generic tests that you get out of the box. And this is unique, not null, accepted values, and relationships. We're going to write our own singular test in addition to using these 4 out-of-the-box tests in our project to show you what a custom test in DBT will look like. And while we won't cover them in this workshop, the final piece that's very important to access other generic tests is to use the packages, both DBT utils as well as other packages like DBT expectations, which brings in tests inspired by the Great Expectations Python package into DBT. If Charles Dickens coded, he definitely would have used the DBT expectations package. Now, when it comes to documentation, DBT brings together both column and model level descriptions that you can provide, as well as details from your Snowflake information schema in a static site for consumption by data team members and also maybe outside stakeholders that are more on the business side of things. So let's jump back over to the IDE and look how we can create some of these tests and descriptions. Now that we're back in our IDE, we want to create the tests and descriptions. And so to do this in DBT, this is stored in a YAML file. So to get started, we're going to create a new YAML file. We're going to create file. We're going to call it core YAML. Great. As usual, when we have large chunks of code throughout, especially this one, we're going to take our tests and documentation for our fact orders model, get it from the Quickstart, and put it into this file. There's a lot of information in this YAML file, and in just a moment, we're going to break it down step by step. One thing that's worth noting about our testing and documentation YAML files is the best practice around these would be to have at least one YAML file for each testing directory that you have. So we have core, and then we have that core YAML file. Now, depending on the length of your YAML files and how either small or large they are, you may want to differ from this, but it's worth noting that this is typically what we've seen works well and to keep the YAML files manageable. Now getting into the file itself, you can see we're starting off at the models hierarchy level here. And within models, our documentation will be for our fact orders table. That's the name. And you can see nothing too long, nothing too complicated. We're just saying that it's the orders facts table that we've got there. So really not much on the description side here. We can see as we get to this next level of hierarchy, our columns is where we have really most of the testing and documentation going on. So looking at the testing in this model within our columns now, we can see that we have the order key. It's the primary key of this model. And we can see that we're working with 3 out of our 4 generic tests that come out of the box with DBT. So we're saying that our column order key should be unique, it should be not null, and we should be testing its referential integrity back to our orders table, our staging orders table. So what this means is that every single order key within our fact orders should trace back to our staging order key as well. The severity is a warn, which means it won't cause our DBT runs to fail. Instead, it'll flag them as a warning. As we scroll down here, we can see our fourth out-of-the-box test within status code. So this is the status of an order, and we have our accepted values. So we're expecting that it either be P, O, or F within that order status code there. So when we take a look at the descriptions, we're able to see that these are split between two different notation styles. One is using the plain text, and the other is using the Jinja doc block. So the plain text that we see here simply works as it does at the model level. You can just type that in, and that will appear. Now, the doc block down here, what this does is this is taking Jinja and it expands our documentation capabilities by allowing us to write descriptions in a markdown file, which we're about to show in the next step. So it's time to build a markdown file so that we can reference the doc blocks. So to do that, we're going to create a markdown file. This is different. We haven't done this yet in this project. So we're going to call it core, which is the directory that we're working .md, which stands for markdown. And we have this piece of code already written in our Quickstart here. So this is a very small doc block. It's worth noting that these can be a lot larger and contain many, many lines. So let's save that. So this markdown file that we have has one doc block corresponding to one column within our doc block description in our YAML file. I mentioned we can have a lot more, but for this example, we just have the one. So the name within quotes in the YAML doc block over here represents the description that's connected with the markdown doc block. So you can see here, what we have is the gross item sales amount. And what this is doing here, in order to grab the description for this column, we are referencing back to our markdown. And we are taking what will become as same as the extended price will become our description. And we'll see this in our documentation. So that is how our markdown and these YAML files are connected together and can help us with documentation. This is really useful when you have either a lot of different lines of documentation, multi-line documentation, so really long descriptions, or also if there are columns that are repeated in different models that you want to have those descriptions get repeated throughout. So it's really helpful to use a doc block in those scenarios. So looking back at our YAML file, the next column that we have that we're describing is our item discount amount. And the description is the item level discount amount. This is always less than or equal to 0. So this seems like a column that would be a pretty good candidate for building a singular test. And that's exactly what we're going to do. So to do this and create this custom test, we'll have to create a new file. Now, for the first time in our project, we're going to go into the test area and create a new file there. So we're going to call this fact orders, since this is the table that this test is being applied to. And we're going to call it negative discount amount dot SQL. Now, remember, our generic tests are looking to return failed rows. So anything that we can write in SQL, we can create as a test. That's what we're doing here. Now, we have a chunk of code that will help us out with this. So we're going to go back over to our Quickstart. We're going to be building a singular test. I'm going to save that. Let's break down the SQL a little bit, since you might be wondering why we have a greater than when we're trying to test values that are actually less than 0. So custom tests, as we've talked about, are written as SQL statements, which we've done here. But the important thing to keep in mind is that a test is testing to return failed rows, so failed records, and that will ensure that our test passes. So if there are no failing rows, our test passes. If there's even one failing row, our test will fail or warn, depending on how we've configured it. So this means in order for our test to pass and that there will be no rows, we need to make sure that this would return failures. So given that our assumption about the item discount amount is that it'll always be less than or equal to 0, if we find rows that are greater than 0, this would return a record. The other thing that you might be wondering about is that our tests are not within that YAML file. So how does DBT know to actually run this test? It's a combination of the file system that we have going. So we have our test directory, and then we have our DBT project YAML. And we configured this before. And we can see that if we go in here, our DBT project is going to look for our tests in our test pathway that we have here. So that's how it knows where to look. And the other thing that we're doing is we're using the ref function so that it knows to test that fact orders model. That way, anytime you want to use this DB test in a model, you can run it alongside any of those generic column tests as well. And this will be done in the next step when we actually run our tests. Let's do it. Let's run some tests and see if what we've written here will properly test our fact orders model. So I'm going down to the command bar here. I'm doing DBT tests and I'm doing select fact orders since I only want to test this one model, and I'm hitting enter. So important thing to keep in mind here is that we have those 4 generic tests and that we also had a custom test. So we should have 5 total, which is what we've got, and we've passed all 5 of them. So we can dig into some of the details of the test. Let's do the fact orders one that we just wrote for that custom test. And you can see that this is what is being run in Snowflake to test that assertion about our discounts of data. Let's switch gears and look into our documentation now. So to create documentation within DBT, we're going to type in DBT docs generate in our command line. We're going to hit enter. And we're going to wait for this to load. We should get a pop-up at the bottom. After this is done running, our docs have been successfully created. And now in order to view these docs, we're going to go over to this little book here on the left panel. So here we're in the documentation website, which is really useful for people who are maybe not coding on the project, but they're business stakeholders and want to understand the integrity and documentation around your project. So we just wrote documentation for our fact orders model. So let's open it up here. And at the top panel here, this information comes from a Snowflake information schema query. And so we can see the approximate size, when this was last modified, and importantly, which schema this has gone to. So we've been seeing this throughout the project that we put this in my development environment. So we wrote a model level description for fact orders, and we can see that this description has now come into our documentation website. The other thing that we can see is that we have columns, and we have both the descriptions that we brought in addition to the tests. And if you hover over those, you can see that we tested unique, not null, and the foreign key relationship test on order key, and then we had the accepted values in the status code. We can also see how the doc block came in for the gross item sales amount. And we can see that it's same as extended price, which is what we put in that markdown file that came in through a YAML to reference that description. Pretty cool. If you scroll down a bit farther, you're able to see information about the relationships this model has with other models as well. And we can also see the compiled code. So both the source code as was written and the compiled code, maybe for people who aren't yet using DBT but want to understand what your model is doing. So finally, in our documentation, we have on the right-hand side, we have the mini lineage here. And this is specifically for fact orders. And then we can also see the entire lineage here. If we go to view screen, and we can see the entire project that we have here through a lineage graph. Remember that this lineage graph is made possible by using the reference functions along the way. So I really can't stress how important that is that it automatically creates this really great lineage graph to see where the dependencies are visually in your project. So that is documentation. So we're going to go back into the IDE. We've saved everything. just checking that we did save everything. We saved everything. We're now going to commit and push these changes. We're going to call this tests and docs. Great. So that wraps out the test and docs section. And that leaves one more area that we'll talk about today, which is deployment. So up until this point on our project, we've been operating in our development environment, which is kind of more like a proof of concept when you think about it, because we're not thinking about how the project or these models are going to scale. And this is really what deployment is all about, is how does this scale and how are we running cadence jobs and making sure that our dashboard views are updated, those sorts of things. So let's talk about environments. So like I said, we've been doing our development work and we've been using our feature branch, which is specific to what we were creating. And we built this in our development environment that was specified through the connection, also in our development schema. So we saw dbt Watson, and that was through that dev connection. So doing this work on our feature branch allowed us really two main things. The first thing is to make sure that we weren't interfering with our coworkers' work and the feature branches that they were building. And the second thing was to be off the path of production code and not have any breakage there, because we could still have dashboards that are live and they need to be using the production data. And together, the combination of using a Git branch and a Snowflake database objects, those two things together form that environment for us. So now we've completed this testing and documentation work, and we're ready to deploy our code from our development environment to our production environment. This is going to involve two steps. The first one is that we're going to promote our code from the feature branch onto the production branch of our repository. Now, I know what I said in the beginning, that generally a production code branch is going to be named and there's a whole review process. You don't just yeet it into main, so to speak. So you want to make sure when this is an actual project with your team and you're not working on a small sort of demo project with a trial repository, make sure you do that QA process. dbt has a very good Slim CI process that will spin up a QA schema. So check that out. But for right now, we're just going to promote the code into main. The second thing that we're going to do is we're going to deploy our code to a production environment. So once our code is merged into that main branch, we'll need to run dbt in our production environment to build all of our models and run all of our tests. This will allow us to produce production-ready objects in that production schema within Snowflake. And luckily for us, the Partner Connect has already set up a lot of this, and we'll just need to tweak it a little bit. So with that, we're about to hop back over into the IDE and set up our deployment. So back in our IDE here, we're going to work on the deployment environment. The first thing we want to do is make sure that we have all of our commits, which we did do that. We did that at the end of our testing and documentation section. So now that all that work is committed, we can do a merge into main. And as we can see, our branch changed up here from that development Snowflake branch to our main branch. Now, all of our development work has been merged in the main branch. We can start to build our deployment job. So given that our production environment and production job were created automatically through Partner Connect, all we need to do is tweak it a little bit, as I mentioned. So we're going to go in the Deploy tab. We're going to go in Environments. We have two environments listed, and we're going to click on the deployment environment because that's what we're working with. We're going to go into our settings area, and the area that we're going to modify here is all the way down here. And instead of having the schema right to that development schema, instead we're going to have it right to production. And we're going to save that. So make sure that's saved. That's all we're going to edit here. All of this is fine to stay the same. So like I said, just that production schema at the end. So now the next thing that we want to do is we want to switch over to our jobs, and we're going to go into this Partner Connect trial job. And there's also not much that we need to update here because it's already created our deployment environment. It's created that target. Now, there is one thing that I'm going to update for the purpose of this demo, which is we didn't have a seed. We skipped that section in section 8. So just to make sure that we're not creating any sort of extraneous code here, I'm going to delete that seed and I'm going to save here. We also are going to create the documentation similar to what we created at the end, but this is after our objects are run and built and they're tested to then create the documentation afterward. We don't need to run the source freshness since this is sort of a demo project. We don't need to enable that. And we don't need any additional triggers, but these are pretty cool. So the triggers, you can either have a scheduled job in dbt, or you can have an outside event, such as a webhook through a pull request or an API. If there's newly ingested data, you can use that with an orchestration tool, but we're not going to worry about that. The last thing that we're going to change here is the name of the job. And so we're going to call it production job. And so that should now update. There we go. So now that we've updated those two little things on our job, we're going to go back to the production job and we're going to hit run now. And this will kick off our production job, and we'll see these new objects being built in Snowflake. So now that we can see our job wrapped up, we actually have an error, and we can dig into what went wrong here. And it was during our dbt test, we had a not null occur on our dbt project. So all of our other models actually passed and were created, and all the other tests passed as well. So this little sneaky first example model snuck in an error here, and you can feel free to troubleshoot this. A lot of times you might delete those first models, the first and second models that dbt creates when it initializes a project. It's totally up to you, but this is really representative of debugging and what you would do in a real life situation. So like I said, all of our other models were created. They ran successfully. We can see that here. Now I'm going to go over to Snowflake and see that our tables and views have been created within this production schema. After all, that's why we kicked off this production job, and we wanted to get a separate schema area. So here I am back in Snowflake, and we can see now I'm in the production schema here. So this has been created. It wasn't there before, and it was created by our job. And I can go into the tables, and I can go into the views, and we can see that all of those were built successfully, even with that testing error that we had on our first model. So everything completed, all of our models ran. The only thing that I want to point out as our last point here is what I'm showing here looks a little bit different than what's in the Quickstart, and that's because we skipped the seeds section, so you won't have the tables called staging TPCH nations or the nations file as well. So there's two tables that you don't have here in this demo that are in the Quickstart. So now that we've been able to deploy this job, if we were doing this in the real world at our company, this is great. We've reached the point in which our code changes have been updated into our production environment and would be reflected in our BI tool, maybe our machine learning notebook, so on and so forth. So this wraps out the technical part of our demo. Congrats on completing the lab and wrapping out the technical content today. So you've learned how to use dbt and Snowflake together to build these transformation pipelines for analytics. DB may stand for database, but it also stands for what you are today, which is a data boss. So you're now ready to apply these fundamentals to your own project if you want. You can also continue to use that free trial and load sample data. Snowflake has plenty of sample data sets that you can pull in, all sorts of subject matter areas, such as healthcare, real estate. So feel free to pull those in, whichever relevant to what you want to do, and continue to use dbt Cloud and build on top of what you learned today. Let's just recap what we've covered. So we learned three main things today. So how to build these scalable data transformation pipelines using dbt and Snowflake, how to establish trust with stakeholders by incorporating these key testing and documentation capabilities, and also how to scale our Snowflake compute within the dbt workflow. So remember, we did that using the extra small warehouse for our staging models and our large warehouse for our MARTS models. So there's some additional resources that are really great to know about as you keep going in your journey with dbt and Snowflake. So join the dbt community Slack. There are nearly 50,000 data practitioners now. So there's a good chance that there's someone who's similar in their journey of adoption with dbt and also has similar questions. There's a dedicated Slack channel hashtag DB Snowflake related to specifically to Snowflake content. And you can also continue your DBT education. There's a lot of great free on-demand courses that you can find linked in the Quickstart. And then finally, contact your DBT sales team if you're interested in DBT Cloud and deploying this at your organization. Thanks so much.
Thank you. Good evening, everybody.
Welcome to Community Update. I'm Elsa Mayer.
And I'm Laith Darausha. Last week, one of our Snowflake data superheroes started developing actual super strength. She hopes to soon use this newfound super strength to break data silos all over the globe, without unintentionally breaking her keyboard.
This just in. Presenters at user groups are becoming overnight celebrities. That's right, folks. They've been featured on page 6. They're trending on TMZ. And it looks like there might even be an Emmy category next year for Best User Group Presentation. What data model could have predicted that?
As many of you have seen, Snowflake recently launched forums in the Data Heroes community, where you can ask technical questions and get quick answers from expert Snowflake users. Here to share tips on how to participate in the forums is our top forum contributor, Dan, aka Danny Data.
Woo! Thanks, Leif. It's great to be here. I've developed a whole philosophy and a lifestyle that will set me up for success in the forums. Just like any performance athlete, I follow a rigorous training every day to ensure I'm always the first to respond to a new question. I get at least 12 hours of sleep, follow a strict diet, and I train my wrist and fingers for maximum speed on the keyboard.
That's very impressive, Danny. What about once you're actually in the forums? Do you have any pointers for community members who might be following your lead?
Of course. It's just as much about the mental preparation as it is about the physical preparation. Every day, I meditate for an hour, repeating my mantra, no question left unsolved. And every day, I also read Snowflake, the definitive guide cover to cover to make sure I stay sharp.
That's great, Danny, but I hate to break it to you. You do realize that it's much easier than that. You really don't need to do anything but stay up to date with Snowflake and keep building. It really only takes about 10 to 15 minutes a day to contribute to the community. Yeah.
Wait, what? Let me get this straight. No training, no routine.
Yep.
I'm fine. Sorry. You know what? This is great. I feel liberated. I need to go tell the community about this.
Danny Data, everyone.
For Community Update, I'm Laith Darausha.
And I'm Elsa Mayer.
Good night.